No,
What happened?
nothing.
Okay. Yeah, fine.
What happened?
Okay. Nothing. Yeah. So yeah. Hello everyone. I'm Manish. Today I'm going to teach about pulse width modulation. Okay. So can I explain in one sentence, Kaushik? What did you search so far about pulse width modulation?
So far I just searched up about why they use it, how they use it, and where they use it. So I learned
Okay.
that
Can
it's
you
a
can you tell
way.
me any one application?
Okay, so it can be used to raise your phone's brightness or lower it. What it does is just it turns the light on and off extremely quickly, making it seem like the light is just really dim, but in reality it's just turning on and off.
Exactly. And yeah. So far you have dealt with digital right?
Yes.
Digital right. So what it does, we only give it as high or else low.
Look.
So which is nothing but 0 or 1. So the LED will not glow totally or it will glow totally. So that's
It'll
what low is 0 volts and high is 5 volts. So the
okay.
question here is, how can I make the LED to glow half the brightness? So in order to make give it half brightness, I need to bring down the supplied voltage from 5 volts to, let us say, example 2.5 volts.
Yes.
But Arduino cannot generate 2.5 volts. It has only a fixed ports, right? You can see fixed 3.3 volts or
You could
5
use a
volts.
resistor.
Mm-hmm. Okay. So if you use a resistor, then
But then it doesn't
the
it's
resistor is
not
for,
efficient.
a
It
resistor
wastes
is
some
for,
energy.
yeah, exactly. It, it the resistor gets heated up, and yeah, even it leads to some of the losses, but more efficiently we can do it by using this PWM signals.
Okay.
And the another reason is yeah, another reason why we keep resist the main reason why we keep resistor is to decrease the current so that the LED won't get burned off.
Yes.
Yeah. So yeah, how can we bring the LED to half the brightness?
By
So the
using
answer is
PWM.
PWM, exactly. So generally we on or off, on or off. If you do it repeatedly, okay, if you do it very fast, then
We just see a very dim light, but we just see
if you do it slowly, then you will see the light is blinking.
like
But if you
on
do it
and off.
fast enough, then you'll see the continuous light.
Mhm.
And by exploiting this fastness, you can even control the brightness as well.
That's
Let's
where
see
it
how.
comes in use for controlling your brightness on the phone or any screen.
Exactly. So yeah, if you do fast switching, it appears continuously, but let us see how we can manipulate it. Uh, First, coming to the word PWM, P refers to pulse, W refers to width, and M refers to modulation. Modulation is like you are changing it, manipulating it.
Mhm. Yes.
Fine. Width,
Modifying.
yeah, width refers to the amount of on time. So suppose initially what we have done is, let us say this is 0 seconds and this is till 1 second. So if we do digital write high from 0 to 1 second, it will be at 5 volts, let us say. But when
Mm-hmm.
you use the PWM signal, if it is from 0 to 1 second, then you keep it high for, let us say, half a
Half a
second,
second. So
and then
that's
you make it low.
50% output, or no, I don't remember the name for this. I remember it like said something
Yeah,
where
it's
it's
a 50%
100%.
duty cycle, we call it.
Yes, duty cycle.
So,
Now I remember.
duty cycle, exactly. So that's what. So typical wave looks like little bit of up and then down, up and down, up and down, up and down. So
Okay.
you have one fixed period, let us say 0 to t, and by manipulating the on and the off time, the duty cycle will be varied. It is very important. Duty cycle. When you talk about the PWM, duty cycle comes into the picture.
Mm-hmm.
So if duty cycle is more, then you can say the brightness is more,
So if it's
or the amount of
70%
supplied
duty
energy is
cycle,
more.
then the brightness is 70% higher.
Sorry, can you come again?
So if the duty cycle is 70%, then the light is on 70% of the time.
Yeah, exactly.
Oh.
70% of the time. So yeah, if you see, this is one time period. This one time period, right?
Mhm,
Time period.
mhm.
And if let us consider it as 0 to 1 second. So it's
Okay.
25% duty cycles refers to 1 by 4. I mean 0.25 seconds of the time it is on, and the rest of the time it is off. So you can see if you want to calculate the duty cycle, it's just on time divided by total time into 100. So on time is 0.25 milliseconds, which is nothing but into 10 power minus 3
Mm-hmm.
divided by 1 second into 100. So what do you get? It's I mean,
What?
yeah. So it's on time divided by total time into 100. If you do this,
Yeah.
you'll get the duty cycle. That's what I was telling.
Okay. Your voice was breaking a little bit. It was like, so on time, like that.
Yeah. So here, if you see, I mean, let me just read. Can you tell me how much time it is on?
25 milliseconds.
Sorry, it's not 25 milliseconds. I converted it into seconds itself. So it's 0.25 seconds it is on, and rest of
Oh,
the time it is off.
which is 0.75.
Yeah, 0.75 is off and 0.25 is on. So if you want to calculate the duty cycle, so amount of on time is 0.25 divided by total time is nothing but 1 multiplied by 100, which is nothing but 25%.
Yes.
That's what. Uh,
Okay.
but I have calculated the 0.25 like from viewers. I saw that duty cycle is 25%, so it's 0.25 seconds. If you consider this total as 1 second of time. So similarly for the 50%, it's like 50% of the time. It's 0.5 seconds is on and 0.5 seconds is off. And similarly for the third case, it's 0.75 is on and 0.25 is off. And in the fourth case, you can see it's whole 1 second it's on. So I just wanted to make a note of this thing. This
Oh.
graph is very important. From here, you can directly interpret and you can understand more clearly.
Okay. Good.
So yeah, did you make a note of it?
Sorry, someone was calling my dad's phone, and this thing is connected to my dad's phone. So yeah.
That's fine.
So duty cycle.
That duty cycle equals to on time divided by total time into 100, which is nothing but duty cycle.
So duty cycle, which is nothing but on time over total time.
Yeah,
Total time divided by 100, or no, multiplied by
divided
100
by on time divided by total time into 100.
into 100 is equal to duty cycle. Okay.
Draw the graph as well. First case, second case, third case, and fourth, and then fifth.
Oh, 5.
So 0% duty cycle, 25% duty cycle, 50%, 75.
Do you want me to write the analog right?
Yeah, and no need of this.
Okay.
We just concentrate on this thing first. And this time period, it may change. Here for simplicity, I've explained you taking this time period as 1 second,
Hmm?
but it may vary. It may be 2
Okay.
milliseconds or 10 milliseconds or some 100 milliseconds or 1 second. So it depends on the application and the uh, microprocessor which you are using.
Got it. And ah, that's 25%. Can I see? Yeah,
Uh, and while drawing the graph, keep in mind that you need to take the width appropriately.
I'm
Don't
trying
draw
my
same kind
best.
of width for all 25%, 50%, and so on.
Okay, well, I'm trying my best.
Yeah. And one more thing, you just keep a strong, I mean, straight line like this, which indicates a proper period.
Yeah, I'm doing that. Okay, now 50%. And number 4, 5 4 mm, 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 mm. 75%. A little bit over here. A little bit over here. And then number 5. We one, two,
Okay. Uh, and also write this analog write value. Just write the value 100% in the
100%.
bracket.
Okay.
0, 64, 127, and 191, 255.
You don't want me to write analog, right?
Value as well. We will discuss it later. Why it is like
Is it
why those
like,
values correspond
is it
to
what we use instead of
50%.
digital, right?
Yeah, instead of digital write, we write analog write. But my question here is why only 64 to show 25% and why 127 to show 50% and 191 to show 75%.
Is it because it uses two two bits? So like it goes by the powers of 2. No.
Okay, okay. If there are two bits, then what are total possible?
2.
Yeah, for two bits, how many combinations you can represent of by in binary?
2.
Two.
4. 4.
Can you tell me what are those?
0 0 0 1 1 0 1 1.
Exactly, exactly. So similarly for 3 bits,
3 bits 9. What is it? So 0 0 0 0 0 1 0 1 1 1 0 1
okay.
1
What
1
if it is for 10 bits? Will you count all those 10?
100.
No, why it will be 100?
Plus 20
Yeah, I told you there is one trick, right?
multiply it by 2.
Yeah, like
I was thinking to the power
if
of
my
2, not
screen
multiply
is
by
little.
2.
Okay, see here. If I have one bit, so
Uh-huh.
you have to fill it with 0 or 1. So the possible combinations are 2. If you have 2 bits, then keep 0 or 1 here. Similarly, 0 or 1 here. So totally, it's 2 into 2, 4
Yes.
combinations. For
Mm-hmm.
3 bits, here you have two possibilities. Here you have 2, here you have 2.
Mm-hmm.
So how much is it? It's 2 power 4,
6.
which is nothing but 8.
8.
Huh?
8.
Hello? Yeah, 8. And 8 combinations it can represent. And what are those values? And the values are from 0 to 7.
What? Yes.
Yeah,
Mhm.
write them down. If you are
Yeah.
forgetting it,
I'm,
write
I'm
them down.
still writing. I'm still writing my duty cycle thing.
Didn't you complete it?
I have to write down like the brackets.
Yeah, fine. Just make it big.
Yep, done.
Yeah, okay, fine. Now, now coming to the number of combinations and the corresponding representations. So in the first case, if there is one bit, what all values can you represent? It's
So it was
0
one,
and 1.
1. So 2.
This,
So
in the second case,
two
it's
to the
0,
four.
2, 1, 2, and 3.
Yes. And 0 to
Yeah.
7, and
Similarly,
then
can you
0
tell
to
me
4.
what if I have 8 bits?
If you have 8 bits, is 0 to 7?
Uh, 0 to 7 is for 3 bits. See,
Oh yeah, 3
here there is nothing
bits.
complex. You just need to think.
2 to the power
For
8.
3 bits, the total number of combinations are 2 power 3. And 2 power
Yes, 2
3
to
is
the
nothing
power
but 8.
8.
And the number of
2 times
permutations
2,
is
4,
0 to
4
7.
times 4, 16, 16 times 16. 16 times 16 is
Yeah,
something. Do you know it? 256. So 0 to
256.
255. So
So
0 to 255.
the value should get exactly.
255.
So if you see here in the previous one, the 100% duty cycle corresponds to 255. Now,
Yeah.
do you get it? So the analog, right? This thing takes 8 bits of in. I mean,
Oh,
internally, it is 8 bits. So whatever the value you give, internally takes as 8 bits. I mean,
oh,
in binary.
okay, okay, okay.
Okay. Now, 255 corresponds to the 100. Yes or no?
Yes,
So 255 corresponds to 100% duty cycle. So
yes.
now you tell me how much pi will correspond to how much.
55 corresponds to 100. And 5 bits or oh, 5.
5. So you can
Uh,
think as 255 as total and then 5 as
okay,
the on time. So it's nothing but
okay.
5 by 255 into 100. If you do it, whatever the answer you get, it's the duty cycle.
Oh,
It's
okay. So
basically
on time upon total time times 100.
1.9.
Okay. Did you use a calculator or what?
Yeah, I used calculator.
I knew it.
Okay. Now, now I want you to tell me what are the values for let us say 191. 191
Um,
divided by 255 into 100.
um, 7.75.
Huh?
75%.
Yeah, but uh, first use calculator and check.
Okay. There's a calculator. So cool. 191 divided by 255 equals to 0.749019601784.
Yeah, to get in percentage, you need to multiply with 100 right again.
Okay, now multiply 100.
Yeah, that's what. Don't
Seventy-four
multiply. You can
point
directly
nine
say
zero
you
one
can
nine
just
six
shift
zero
two to
seven eight
two
four.
decimals. So it's
Okay.
74.9.
019
So
607
yeah, yeah,
eight
that's
four
fine. That's
three.
fine. What I want to tell is 74.9. It is approximately 75.
Which is approximate.
Yeah. Now can you tell me what's 64?
64 is approximately 25.
Exactly. So whatever things we have written here, 127, it's approximately
50.
50. So the actual value is 49.8, but
Zero
it's
six four
approximately 50.
six five four three two.
That's wrong. It's another number. So the main goal here is to make you understand if you write any value in that analog, right, you divide it by 255 and then multiply by 100. Then whatever the percent you get is the percent of the duty cycle. And whatever
Approximately.
the internal value we are yeah, giving, it is 8-bit. So you cannot give more than 255.
Oh,
You
what
cannot do
happens if
this.
I give more than 255? Will it
Yeah,
just say
simply the code
error?
throws you an error. You can compile and dump it in the board.
Are there ones that use more than 8 bits?
Yeah, it depends. That's what I said, right? It depends on the microprocessor.
So what's the most powerful microprocessor in the world?
I don't know. I leave it for you to check it out and tell me
How
in the
many
next chat.
bits? How many bits? How many bits?
But not now. After the class, you inform me. I mean, check it and tell me. Fine.
Okay.
Okay. And yeah, write this thing down. So did you write it?
That's right. What?
Yeah, that's what. 255 and analog write. The input is 8 bits, and to get the corresponding duty cycle, you just let us say if it is analog write x and x is less than 255, less than or equal to, and the amount of duty cycle is given by x divided by 255 into 100.
Two.
Fine. You
What?
understand inequalities, right? So x
Yes.
can take the values 0, 1, 2, so on up to 255.
Yes. Uh-huh. So if it is less than or equal to 255, then x upon 255 times 100 is equal to duty cycle.
Yeah, it's percentage. Yeah, exactly. Percentage of duty
So
cycle.
if analog, right, parentheses x, and then x is less than or equal to 255, then x upon
Yeah,
255 times 100 is equal to duty cycle.
exactly. And
Okay.
and it depends. Let us say I have some. Let us say I have another microprocessor, which in which the analog write. Suppose there is this analog write command in that microprocessor as well. If it is, let's say, 10 bits, can you tell me what's the highest value this X can take?
The highest value to
Hmm.
for yeah, okay. Um, so that would be 2 to the power 10,
Minus
255.
1. 2 power 10 minus 1, which is nothing but
Oh,
1023.
not
Did you get
even the
it right?
world's strongest. Yes, I get it.
Yeah. You just check after the class.
Okay.
So yeah, that's what 25% is like on and then off, 75% on and off. This 50%, sorry, and 75% is on, and the other 25% is off.
Hmm?
And yeah, this is a formula which I told you already. So on time divided by total time into 100. And this total time, it refers to this one, total time period.
Okay, got it.
And suppose on is 3 and then off is 1. Can you tell me what the duty cycle is?
The duty cycle, if it is on for 3 and off for 1,
Yeah. So
75%.
okay, then tell me this one. So if it is on for 1 and off for 3,
It's 33.3333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333433E One by
25%.
four. I was thinking 1 by 3. My fault.
Yeah, I know. So keep it a question and write the question. If on time is 1 millisecond and off time is 3 milliseconds, calculate the duty cycle. And in the answer, do
Equals 1 milliseconds, and off time equals 3 milliseconds. Equals 3 milliseconds. Then 1 over total time, which is 1 plus 3, which equals to 4. So that means 12 times 4. So 1 over 4, which then equals 0.25 times
That's fine.
100
Now you tell
equals
me this one.
125.
If on is x seconds and off is y seconds,
Cycle.
can you tell me duty cycle in terms of x and y?
X upon x plus y. Yeah, x upon x plus y times 100 is equal to duty cycle.
Exactly, yeah. You can write this as question. One more question. Like if on time is x seconds and off time is y seconds, then duty cycle is nothing but x by x plus y into.
So x upon x plus y times 100. Okay, got it.
Okay. So actually PWM, it doesn't create any new voltage. It only switches on and off between these 5 volts. But depending on the duty cycle, if you take the average value, it appears like if you keep 25% as duty cycle, internally it is on for 25 and off for one time period. So similarly, you'll be having many time periods, right?
Yes.
Hello? Yeah. So if you take for total time periods and then do the average, then the total voltage will be around 1.25 volts.
Okay.
Get it?
Yes. Did it go over 1.25? So like 5 volts.
Like you can directly take the percentage as well, like 25% of 5 volts, which is nothing but 25 divided by 100 into 5,
Okay.
which is nothing but 1.25.
Mm-hmm. Got it.
So similarly, if it's 50%, the average value will be 2.5, and this for 75, 3.15, and 100 it's 5 volts.
Okay.
Hey, sit down. Just
My
sit
legs are.
properly. Okay. Now get the Arduino board and just see for these marks.
Oh yeah, I
See for
remember
these
this. I
marks.
saw it in the video. So yeah, the curly things.
Uh, so when you see these
MFA
curly things, it means that the
965.
corresponding pin is compatible with the PWM. It means
Uh-huh.
that those pins can produce the PWM
Yeah, it
signal.
shows it on the Arduino itself. It shows digital exclamation point PW aim and then curly thing. Yeah, so like maybe
Mm.
you can't
Yeah,
see, but
exactly.
there.
Yeah, I can see it. I can exactly. Now, yeah, just make a note in the notebook. The curly thing represents the PWM. I mean, the corresponding pins can generate PWM. And one more thing, uh, the thing how you will configure, like how you can configure is by using this
Okay.
analog right. You just
And the
specify the
10
pin
on the
here
value.
and then the corresponding
Value.
8-bit value over here. So
Okay.
it should be strictly less than 255.
Okay.
So you can write this as well. So analog right
40.
bracket, corresponding pin, and then the value.
Okay. So it could be like 11 comma 40.
Exactly. 11 comma any value you want according to the duty cycle.
Mhm.
So if you want 50%, you put it as 127.
Okay.
Okay. Did you write this function? So this is very important. This thing you need to remember because while doing the code, you need to write this one.
Okay, go ahead. Always
Fine.
and log right and then pin comma value. Okay.
Okay. And the pins which are compatible are 3, 5, 6, 9, 10, 11.
Actually, it is 11, 10, 6, 5, 3,
Okay, fine.
and 9.
So it depends. So it is 11, 11.
10, 9, 6, 5, 3.
Yeah, that's what I told you, right? Everything is covered.
Yeah, you told me that.
Uh, and yeah, I want you to see while testing, I want you to put, let us say, another value which is not there in this, and check whether the code is compiling or not, and also put a value greater than 251, check whether it's compiling or not.
Okay, got
Yeah.
it.
And one more thing, as I told, whatever the period we considered, it depends, it changes according to the processor. And for us in the Arduino board, whatever we are having, if you see the corresponding frequency, to get the time period from frequency, you need to do 1 by frequency. Then you will get the time period.
Okay.
So I want you to write this formula as well.
So
Time period is equals to 1 by frequency.
time is equal to 1 by frequency.
Time period. Time period.
Okay, it took the time to load. Uh, time period is equal to 1 by frequency.
Yeah, exactly. And if you see the photo here, 490, 490, 490, 490. So I need to check the manual whether uh, the manual of your board, whichever you're using, whether
Mhm.
these pins corresponds to these corresponding frequencies or not. But typically
Okay.
these pins 3, 9, 10, 11, 3, 9, 10, 11, their frequency is 490 hertz. Can you tell me
Okay.
what the time period it will be?
Um, it will be 1 by 490.
Yeah, that's what, how much?
Uh,
It's
Give me around 10 seconds.
so it's 0.002 seconds, which is nothing
Oh,
but approximately 2 milliseconds, you can say.
okay, okay.
So
So it's
whatever the
actually
time period
zero
we are
point
having,
zero
it's
zero
nothing but
two zero.
2
Actually,
milliseconds.
it's zero point zero
And
zero two
whatever
zero
the
four zero
analog
eight
write
one
value you are
six three
giving,
two.
that write value you are turning on within this 2 milliseconds. If it is 127, it's like 1 millisecond it is on, and the another millisecond it is off.
Okay.
So this time period it depends. So you can make a note of it. For 3, 9, 10, 11, the frequency is 490 and the time period is 2 milliseconds.
3,
And for 5 and
9.
6, it is 980 hertz.
So 3,
And
9, 10, 11. Time period
980
is equal
hertz,
to
it
2
corresponds to
milliseconds,
approximately 1 millisecond.
and
1,
frequency is
2
equal to
milliseconds.
480 hertz. And for 6 and 5, time period is equal to what? 1 milliseconds. And frequency is 980 hertz.
So
So
if I tell you duty cycle is 25%, can you tell me how much time it is on and how much time it is off in case of 490 hertz?
it is on 25% of the time and off 75% of the time.
Yeah, in case of 490 hertz, can you tell me how much time it is?
Okay. So 25% of 490.
Not 490. You need to consider in time. I'm asking you in time, right? So
Oh, of 2
25% of
milliseconds.
2 milliseconds exactly.
Oh, that's gonna be 50.
That's zero
So yeah,
point 0.5
5.
milliseconds.
Yeah, so 0.5 milliseconds.
Right?
Yeah.
Similarly, in case of 980, it is 0.25 milliseconds.
0.1 millisecond. I mean, wait, what the?
What? For
So
980 hertz, it's 1 millisecond, right?
0.25. 0.25.
Exactly. So you need to be careful. So yeah, can you tell me if I write analog write 9, so it is
Hello? 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 Are you there?
for 9? Yeah, sorry, am I audible now?
Now you're audible.
Is my screen visible?
Yes.
Fine. Yeah, that's all. Can you tell me in this case, 128 corresponds to how much duty cycle? Oh my God, here only
Uh,
it's 50%.
about 50%
Yeah,
approximately.
exactly. Yeah, and this thing I already told you, it's 0 to 255, 8 bit. And yeah,
That
this
thing's
is your
actually
homework.
wrong. The table's wrong.
Why? Why?
The value should be 127 and 191.
Yeah, like it's approximately equal to 50, right? We are not giving exact
It
value. We
is.
are telling it as approx. Right?
Okay, fine.
Okay. Now the homework is in the previous videos you have connected to the digital pins, and then you turn on the LED, right? You turn on the
Yes.
LED by connecting to the digital pin in the Arduino.
Mm-hmm.
Now your task is to yeah, sorry, I forgot the resistor here. So now your task is to replace this digital pin with analog pin.
What's the analog pin?
Yeah, just now, sorry, I mean PWM pin.
What's a PWM pin?
Uh, that's what we are discussing so far, right? So
Sorry. So I use the same LED.
yes, use the same LED. Like these are the pins, analog PWM pins, 3, 5, 6, 9, 10.
I know those. I was like, I thought you were talking about like a different LED.
No, no. Just use the same LED, which is good, like which works well. Not that RGB LED, which red was very dim.
Yeah, so it's
Okay,
not good.
take one good LED, then check for 255 whether it is bright, like it's good or not, and then for 0 you check it, and then you just try to put the random values like 74, 75. Then just check whether first check the corresponding duty cycle, and then you just compare.
Okay, got
Okay,
it. Mm-hmm.
so this is your homework, right? You need to do it, and here. Uh, so the code looks like this. You just put pin mode and then analog
LED
LED,
up.
because
You want me
already
to
you have
name it
defined LED
LED?
equal to 9.
Okay.
And then, yeah, for 0
And then
off,
kind of just test it out.
50, and it's around maybe 80%. So just check for some values. Okay.
Okay, yeah, got it.
Yeah. And now if you look at this code, once can you see the code?
Yes.
Okay. So LED is 9. This is fine. Now the loop, first loop, you can see for int I equal to 0, I less than 255, I plus plus. It means I equal to I plus 1.
Oh, okay.
So let us see at iteration 1. Let us see. So initially I is 0, yes or no?
Yes.
And then analog right. So at 9, this I will be in the first iteration, I is 0. So LED is off, yes or no?
Okay. Yes.
And then it will give a delay of 10.
Okay.
milliseconds.
Okay.
And then, and then
It is
again,
on.
and then again, the condition, see the condition, 0 is less than 255 or not?
Yes, it is.
So again, the I will be incremented, so 0 plus 1. So I value is 1. Now, analog, right? Now I value is changed to 1, right?
Yes.
So now you can see in the second iteration, after 10 milliseconds, you can see the 1, I mean, I value is 1. So there will be little bit of turning on. It will
Okay.
be near to 0, but it turns on. If you
Yeah.
calculate the duty cycle, 1 by 255, so it's around, it's very less, 0.3% you're getting.
So you can barely, possibly
Yeah,
not even
barely
see
notice
it.
it. And this is for the second iteration. Now let's go to the third iteration.
Okay.
Uh, Before going to the third iteration, check the condition. Now I value is 1. Is it satisfied? I is less than 255. True or false?
Yeah.
True. So the I value increments. So 1 plus 1. So I value becomes 2 now. So again,
Okay.
it goes into the analog, right? And now the I value is changed to 2. Now the
Okay.
duty cycle is increased from zero point 0.3 to zero point 0.7.
So it just keeps on increasing by one
Yeah, increasing by 1. But till when it will increase?
till it reaches
It increased till
255
255.
or
Once
254
it
because it
reaches
needs to be
255,
once it reaches 254 because it needs to be less than 255.
yeah, exactly. So once it reaches 254, and then it gives the corresponding, I think, 99% duty cycle, and then again it goes into the loop, and in that case, it's 254, right? So it is less than or equal to 255. So again, it will increment, and again it will go inside. So it will write as 255. Now, after I value is 255, now
Mm-hmm.
it goes and checks, yeah, it is less than, and is less than 255, and then it gets incremented. It becomes 256.
Oh, okay.
Now it doesn't go.
Oh, then it just stops.
Yeah, it stops. And then if you see the second loop, it is similar. I value is initiated to 255. And now the condition is I less than greater than or equal to 0, and then I minus. So it's nothing but I equal to I minus 1. In the previous case, I started from 0 and it incremented all the way to 255.
Yes.
Now in this case, I is starting from 255 and it is getting decremented all the way to 0
Okay.
because this is the condition.
Mm-hmm.
You just check with the iterations. You just see for first iteration, I value is 255. For second iteration, I value is 254. Third iteration, I value 253. So it keeps on decreasing. And
Until it
after every
reaches
value,
one because it needs to be greater than zero. Got it.
yeah, greater than or equal to 0.
Oh, okay. All equal. That's how the equal to. Okay, got
Okay,
it.
so I value becomes 1 and then
Zero.
uh, it goes inside and yeah, I value becomes 0 and it goes inside, and now I value becomes -1, it doesn't go inside, it just comes out of the loop. And then this total thing is in the loop void, so this thing runs and then this thing runs and then again these two things will be looped again. So in the
Oh,
first case you can see LED will go from low to high slowly, and in the second case you can see the LED goes from high to low slowly. So this is basically a for loop. You just initiate the variable here and then give the corresponding condition,
mm-hmm.
and then the corresponding increment value.
Okay.
So now do you understand the for loop or you're having any doubt?
No, I understand it.
So it's just simple. If you have any doubt, then just write the iterations. Just check for each iteration how much it is. Then you'll get clarity.
Oh, good.
Right. Fine.
It's fine.
Yeah. And then yeah, apart from LED, we can even control the DC motor speed, servo motor, and then computer cooling fans,
I talked
heater,
about that.
exactly, and robotics and drones as well.
Okay,
Actually,
got
in the drones, you have these propellers, right?
it.
So this propeller, the amount of rotation this propeller should
Oh,
get,
kind of like a fan
that's
in the sense.
yeah, exactly the speed of the propeller. The microcontroller, we write microcontroller as this mu p. So this microprocessor, it will send the PWM signal. So if you want the drone to go more height, you just increase the PWM duty cycle. Then it will rotate very speed and then it will go fast.
Okay, got it.
And suppose if you want the drone to move forward, then you just decrease the duty cycle of forward two propellers and then increase the duty cycle of this backward propellers. So then
Uh,
the drone, it goes forward.
uh-huh.
Yeah, you just imagine, like initially it is in straight, and then now you just decrease the speed of the propellers in forward and increase the speed. It just leans forward and then moves forward,
Okay, got it.
like kind of this way, and it moves forward.
Mm-hmm.
These are the back and these are the front.
Okay, got it.
So that's all. Like these are having very pretty interesting
Mhm.
applications actually.
Yes. And it's perfect for computers.
Yeah, and yeah, the takeaway is this function. It takes the pin and then the value, and the rest is it's your skills. Use for loop, while loop, use whatever you want, and then play with it.
Okay. Mm-hmm.
And yeah, so yeah, for this one, can you make it quick? It's 6 by. Hello?
Okay, so 75%.
Yeah, exactly. For 128, it's
50
I think
or
it's 50%.
approximately. Approximately.
Okay. Now you tell me for 75%, how much should be the X?
Oh, um,
You just
it
you
should
just
be
plug in the variable. Let us assume the value is X, and then X by 255 into 100 is equal to 75. Now you just send the 255 that side. So 75 into 255 divided by 100. Can you tell me what the answer is?
75 into 255 divided by 100. So 75 into 255, which would be okay. Oh, 191.
So exactly. Now you understood, right? How to do the reverse calculation as well. If I give some, let us
Yes.
say 30% duty cycle, how can you get the corresponding analog X value?
30% duty cycle. How can I get that? But what?
Yeah. Come on, tell me for this one. Suppose the duty cycle is 30%. In analog, right? How much should I give?
It would be so it would be the pins analog, right? Let's just say 9, comma, so 30%, 30%, 30%.
Yeah, you just put it in the book, you'll get it. Let us assume the value is X, then X divided by 255 into 100 should give me 30%.
30%.
You just,
So
yeah,
that must be
X
35
divided by
times 2.
255 into 100 should give me 30. If I want to
Yes.
find the value of X, you just send 255 that side and 100 this side. So X
So
equal to
30
30 into 255
times
divided by
divided by.
100.
Okay.
Yeah, you make a note of this, put a question. Let us say if the duty cycle is 30% and what should be the analog X value? Assume it is used in 8 bit, up to 8 bit. Are you writing it?
I closed my book, so I'm trying to find my page.
These things you need to write because
I got it.
without these
So
calculations you can't.
what did you want me to write?
Yeah, whatever you have discussed, like let us say write a question. If the duty cycle is 30%, then what is the corresponding analog X value, considering the input is 8-bit only.
Okay. Equals 30%, and it is 8 bits. 8 bits. How much is X? How much is X? So that would be X upon 255 times 100 equals 30%. So now I have to do it reverse order. So 30 times 255 upon 100 equals X. Okay, got it.
Okay, can you tell me similarly for let us say 55% duty
Wait, give
cycle?
me 5 seconds. I need to put charger in from my MacBook.
Hello?
Yep, I am back.
Yeah, yeah. Can you tell me what will be the corresponding X value for let us say 76% of the duty cycle?
76%. Can I use calculator?
Yeah, fine.
Yes. Okay. 76%. 76%. 70%. So 76 times 255 divided 193.
Okay.
Or approximately like 190.
Okay. Okay. Now I have another question. Suppose if the analog value X can take up to let us say 10 bits.
Mm-hmm.
Now can you tell me to get 75% of duty cycle, what should be the value of X?
Okay, so 2 to the power of 10. 4 times 256 is
Come on,
one
do it.
zero. Wait, I got you.
No, it's a little bit tricky.
I no, it isn't. So 1023. So 76%.
Yeah, to get 75%, how much should be the analog value?
Uh, to get 75%.
Huh.
So 75%. 75 times 1023 equals 767.
Exactly. So if it is, let us say, 11 bits, so you just
Um,
so multiply
two.
with 75 into 2023 divided by 100. So it depends on what value here you multiply. So number of bits, tells you about this maximum value, whether it is 255 or uh,
Uh-huh.
15 or
Right.
3 or 1023 or 20420.
Yes, I got it.
What is it? 1024, 1024, 48. So 2047. So it
Mhm.
depends. Okay,
Okay.
fine. Any questions? Any more questions?
No, no.
So what is the homework for you?
Experiment with it.
Yeah, and then video on.
Hello?
Hmm? Yeah,
Take a video.
yeah. Here is your homework. So I want you to first explain a little bit about the duty cycle,
Okay.
and then second one, just take analog x values of let us say uh, 0 and then 64 and then 121 and then 255. Calculate the corresponding duty percentage. Fine.
Okay.
And then first to explain, 0 corresponds to this much duty percent. So I am putting the 0 in here and then run the code and show them the LED. And second
Okay.
case, do for 64 and then run it, show the LED.
Okay.
Third, run LED. Fourth, run this and show the LED. And after this thing, uh, we discussed about the for loop, right?
Yes.
So I want you to implement this as well. So
Mm-hmm.
explain these two pieces of code
Got it.
and then try to experiment with this.
Okay.
Fine? Cool?
Okay. Yeah, cool.
Any
Okay.
more questions?
Nope.